Hello guys, and welcome to another multiple apps workflow tutorial with me, Eldrin from Longitude Lemire. Today we're going to be going over Arnold Scene Source manipulation and batch rendering. So this will be the last in kind of sort of this introduction to Arnold series. I'll be going into another series where I'm going to be talking about very specific workflows on how to get certain shaders set up and different things like that. I'll also be starting a Patreon page, and I'm going to start going into more production-oriented scenes. So we're going to be doing some really cool stuff over here where we're going to be actually putting out films and shorts and showing how, in kind of a sort of a true production fashion, how those scenes are put together and how to combine elements together in a less theoretical kind of sort of way and more of a, we got this project and let's go ahead and put that together. So for this particular tutorial, what we're going to do is we're going to take our test of forest walker scene, which you've seen in a previous tutorial, and we're going to go ahead and use the Arnold Scene Source export capabilities to go ahead and export this out. So we already know that we can use Arnold Scene Sources to import directly into our scenes and use those to add procedural elements from various different packages, Arnold, Houdini, Softimage, and use those in our scenes. And we're going to be taking a much deeper look at that in a future tutorial where I do hair workflows and Maya and bring them into Cinema 4D for render. But ultimately, when you get ready to use Kick, the command line renderer from Arnold, you will ultimately be rendering out Arnold Scene Source files or AS files via the AS export here. And that will allow you to render those files basically on any render farm or any machine, Windows, Mac, or Linux for that matter, that has Arnold installed and has an Arnold license. This is an important concept. The Arnold team does give away the Linux renders or the Linux shaders for C4D upon request, and those Linux shaders are will allow you to render in Kick on Linux without any installation of C4D at all. As we all know, C4D doesn't actually run on Linux, but Arnold does, and so you can create quite a few cheap machines that way, and cheap, very stable machines that render extremely fast via Linux, and just have Kick on those and just pass out your files to it. Alright, so enough ado about nothing. Let's go ahead and get into this. So we've already set up our driver, and we've got a few AOVs that we've discussed in our AOV tutorial. Alright, we've also set up the file path for the driver, and all this information basically goes into the AS file in a specific format that details to Kick where to export things out and how to generate stuff. So if we go ahead over to our render settings, let's see. Let's look at our render. It's 0 to 72. Let's go to our output and let's do all frames 0 to 72 and check our render settings, make sure everything is kind of good. Coming over here to our motion blur, let's make sure that that's set up correctly. Cool. Let's make sure our depth of field is also on and good to go. See, it's enabled. Our shutter start is set at 5, which is the same thing as the length here. And we're all set for render. So what we can do is we can come here to our AS export, and we have quite a few options here, of course. Starting here at the top, we have the gzip compression, which is quite useful, and I would highly recommend checking that. You can leave it unchecked as well. We're going to do that in this particular case because we do want to analyze our AS files here and have a deeper look at what is going on inside of them. The as table of contents is useful for procedurals, as it will allow you to see that bounding box that we saw for our trees. The binary encoding will allow the Arnold Scene Source exporter to basically export out geometry in a more binary fashion, so it's less human readable. Pretty easy for you guys who are a little bit more familiar with programming and can understand hex a little bit better. But for most of the normal laymen, it's going to kind of sort of encode your geometry in kind of a weird way that does reduce file size, but makes it a little bit less readable in case you were ever trying to like actually change a single triangle or something like that in your Arnold Scene Source. Expand procedurals is going to go ahead and expand out any Arnold procedurals you might have in your scene and basically blow them up. So that's going to blow up the Arnold Scene Source file size. But at the same time, you won't have to actually have those procedurals exported to whatever systems you decide to render farm on. So if you have like 1,000 Linux machines, you can have just one AS file go out to them versus a whole package of files. That just makes things a little bit easier for you to manage. The options are the global Arnold options. So if we go into our render settings here, that's going to be these options here for your AAs and various other different globals that define how the scene is actually rendered. In a stand-in or a procedural, you probably would turn that off. But in a final render scene, you're going to need those in order for Arnold to be able to figure out, oh, okay, I need to render with this specific type of AAs and all that kind of good stuff. The cameras are naturally the cameras in your scene, and they're going to allow you to, of course, be able to see your scene at a specific visual angle that you set up in your animation. So you definitely want that for this kind of export. The lights would be all your basic lights, and that's going to allow you to see your scene as you see it in the IPR. The shapes and the shaders are two of the most important things to export out when you're talking about exporting out a procedural. Usually all the rest of these would get unchecked by me typically when I'm doing a procedural, because the shapes is all the polygon objects and particles and points and all that kind of good stuff, and the shaders are the materials, and that's all you really need in a procedural to basically create procedurally generated scenes that have like a lot of geometry. Alright, so we'll turn all these back on. The drivers would be this EXR driver here, or any other driver that you created. So if you want to render in deep EXR, you certainly can. The C4D display driver is going to allow you to be able to see your AOVs here, in your IPR, and in the picture viewer. So you can always, of course, create two drivers. And if you want to see your AOVs in the picture viewer, that would be a good idea. So I've renamed my EXR driver EXR. And then naming convention wise, I like to name my other drivers related to what their meaning is. So this driver is the C4D driver, and it's going to be the driver for the C4D display. And then I can merge its AOVs, go ahead and set up AOVs. I can add different AOVs that I want to see in my final render. So I can add all my masks, and I can add my Z and motion blur. And now I have two drivers. This driver will get ignored by Kick because it's only specifically dedicated to C4D to A. But here in C4D to A, if you were to render with the picture viewer traditionally in Cinema, you would get some AOVs now. And in fact, you can see them right here. So that's the C4D driver. EXR driver is going to render exactly where we told it to, and it's not affected by the fact that there's another driver in here. And then the filters are global filters that Arnold can apply to do various different things. There are some default ones like the Gaussian blur filter, which is going to do a little bit of a Gaussian filtering on your image to make it look prettier. And then there are other filters you can apply that do different things. So here's the default filter type, and you can change the filter to whatever your heart desires. Blackman Harris, I use this in isotropics a lot to get like really good anti-aliasing. and then you can change the filter width. The default filter is Gaussian, does a pretty good job. I haven't changed it yet, ever, but you know, based on your understanding of filters from any other render engine like V-Ray or standard render, you might want to change that filter type and see whether or not you get better anti-aliasing or worse anti-aliasing. Just play around with that. And that is all the options. So here in the AS export we have more fine control. So we did set up our output here, but here we can set our output to current frame, or we can create a custom output that will render out an AS file export completely different than what we defined here. Or we can use the render settings and just use C4D's interface and export that way. And then once we're done with all that, we can export out either selected objects, so we can define specifically what objects we want to export into this AS file, or we can export all, which is what we're going to do. So let's go to our folder here, and you may notice my interface looks slightly different or drastically different than it looked before, and that's because I'm using Windows 10 now, and I've been testing it for a few weeks now, and it's very stable. None of my 3D graphics programs have ran into any sort of hitches like they did with Windows 8, and so yeah, this is my new norm. I'm probably not going to go back to Windows 7 at this point. Let's see, so we're trying to go into H documents here, and we're trying to go into test 2, and then we have the Forest Walker scene, and we have an Arnold folder, and we have this batch file in here that we're going to go over in just a few moments. Before that, let's go ahead and make sure that we do an underscore here and add some hash marks. Once again, these pound symbols allow you to define a certain number of placeholders for sequence numbers. And After Effects uses this, Nuke uses this, Arnold uses this, and there are quite a few other renderers that also use this pound symbol type of functionality. So once again, like I mentioned in another tutorial, you probably want to get used to doing that, especially in Arnold here, for defining that you want an actual sequence to be rendered out. Otherwise, what will happen is this will render out, it will render over forestwalker.as 72 times, and basically what you'll end up with is just one frame, frame 72. You won't have any of your other frames. So anyway, let's do an export all, and C4D is going to go through and it's going to export all that. And here in Windows 10 we can use our new task view, which is quite similar to the Mac mission control. I really love that on the Mac, the whole mission control thing, allowing me to just quickly 3-finger swipe up and kind of sort of get a nice big view of what's going on. We also have multiple desktops here in Windows 10 as well, allowing us to split up our workflows, especially if we're not using multiple monitors like I'm using right now. But let's see, we're going to go into the Forest Walker, and we're going to go into our Arnold folder, and go ahead and start to see these Arnold files populate in here. And they don't appear to have, oh, I know why. This is my server. So they didn't actually populate here. They would have populated here on my work drive. And so there we go. We've got our sequence. Excellent. Now, research and development wise, I've been looking at alternate workflows, and I've been doing a lot of research with C4D. A couple of things that I've done is I've consolidated all my textures into a textures folder now, and I've basically created textures per scene. That way all my textures are consolidated into one place. And here in C4D you can go to your preferences and you can set up that texture location under files here as a texture path, and then you don't have to actually use the TX folder in C4D, but you can actually use this texture path, and every texture that's in there will be relative to your scene. And that way you can consolidate some memory, save some memory and stuff like that, and it works around kind of sort of the heavy and kind of sort of flinky issues that you run into with XREFs. I've kind of dropped the XREF workflow from my general usage because of a lot of different things, and they also at first didn't really work very well with Arnold as well, so I didn't like that either. A couple of other things related to that workflow. I've also created a new asset template kind of sort of workflow a little bit. So, you know, whenever you're creating a new shot or character, whenever you're creating a new film, music video show, basically, you know, I have my basic original textures and textures folder. The original textures are my PSDs and my TIFFs. The textures folder would be any of my TXs, and they can be used in isotropics, they can be used in Arnold, and there are a couple of other renderers that also support TX. TXs are tiled, and you know, there's a whole bunch of benefits to why they're better than normal texture files. And so it's really nice that, you know, both isotropics and Arnold, which are two of my major renderers, use that. Shot character would include all folders that are related to any sort of character. So whenever I create a new character or a new shot, basically I just copy these folders and paste them into the new character, and I'm just off to the races. I've created some base files here, an Arnold base file that basically has settings for 4K and 720p here in my render settings. Has it all set to 24 frames per second for me automatically and everything. So I can just rename that and go. It's got a TX folder just in case I decide to use the local TX folder in C4D. My Premiere Pro project has a Premiere Pro template that has everything all set up nicely for me. The Arnold folder has the Arnold batch renderer and the Arnold interactive renderer batch files that I've scripted that allow me to kick off kick really fast. And After Effects has some defaults as well set up under this composite AE file. So, you know, that's just kind of a quick way. If you want to set something up like that on your hard drive, you just basically create a bunch of folders, go into your various different programs in your pipeline, go ahead and set up some default files in those different programs with you know, basic settings that you want to use in your projects, and then you save all that stuff out. Alrighty. So here in Testa 2, one of those files that comes with the default kind of sort of setup that I have here is that Arnold batch file. And if we take a look at it, so we can edit this in a text editor. What it does is it creates a variable here in the Windows command line. So I can go ahead to my command line here, and basically I could run this command in the command line, and it would set whatever directory that I have here as my my process directory. So basically the directory that this is running in right now here is going to be the process directory. Then it changes the path over to my render farm version of Arnold, which I've set up custom from the M2A. I basically used the M2A initial deployment and created a copy and just basically added in all my own shaders here. And I added in all the procedurals from C4D. I added in the C4D shaders, all that kind of good stuff. And then here in the bin, we've got the kick, and we've got the make text utility and the AIDLL. And so it points to that, and basically it can process via that kick. So it does a for loop, which is just basically a processing loop, goes through, based on the files that it finds in there in a sequence, it goes ahead and runs kick for each one of those with these options. So no render window, verbosity of 4 gives us a nice log of a bunch of stuff that we can use to diagnose our scene. I limit the threads to 4. I have 8 threads because I have a quad core machine, and it's Intel, so it's got hyper threading. But if I use all 8 threads, my computer will lock up. I won't be able to do any work on it. So we limit that to just 4 cores. I could probably up this to 6. My computer will start to become a little bit sluggish at 6, but I'll still be able to kind of sort of work. 4 is a pretty nice compromise. Obviously, if you've got a machine that is running like a 6 core, you know, you have 12 cores, or if you're running double 6 cores, maybe you're running a workstation or something like that, you can certainly up this number up and you have a lot more horsepower. Either that, or if it's a render farm machine, you can just leave this at max, and because you're not going to ever touch that machine for any work, you know, you can just let it just kill itself rendering in Arnold. So it's pretty awesome. So you can pause the video and basically copy this, type this. I'll try to get this up on the website as a script in my my store a little bit. It'll be free, but it'll be easier for you guys to probably download it instead of having to write it yourself, because all these little % signs could get a little hairy. You might miss something. But if you want to pause the video right now and try to write this down while you wait for me to actually get this up on the website, that'd be great. And that's going to be your batch script. So you basically place that in the directory that you want to render from. So we're going to go back a few here and forward. There we go. And then you just double click that and it runs. Now, just in case it kind of sort of craps out right away, what I like to do is I like to actually run it directly from the command line myself. So to do that, you probably will want to actually go into your directory itself, and this is not really a command line tutorial, but basically you would flag whatever hard drive you want to actually go into. So H : will basically put me on H drive, and then from there I can do a change directory, and I can change my directory to this directory here. So I'm going to go ahead and click in this white space here, any white space in this address bar. Go ahead and copy this, come over here, paste this, and then hit enter, and it's going to put me in that directory. I put that CD there, that's the command for change directory. And then I can just run the Arnold batch. So I can just type in AR and hit tab, and it'll autocomplete for me because it knows that file is in this directory. And if I hit enter, it's going to go ahead and run Arnold. And I have this weird shader issue that I still have to kind of sort of figure out. Okay, it's related to the kettle shaders, which I can just go ahead and actually delete out of there since I'm not really using them. And that will clear up that error. So it's going to basically come up with this dialog every single time it renders an image, and that's going to get annoying pretty quickly, because if you want to basically let this run over the course of the night, once this error comes up, it pretty much freezes the render process, and you'll wake up tomorrow and you'll see that your frames aren't done, and you'll be highly upset with yourself. So probably go ahead and delete that shader. And then yeah, more kettle shader errors, and then finally it's going to go through, and Kick is now command line rendering out this file. And then because I set the verbosity to 4, I'm getting like a lot of information about my displacement paddings, what AOVs are being generated, how many buckets are being used, how much memory is being used by my scene, how many different nodes of different types there are. So, you know, we set up that AI flow noise to do some stuff with our text. We have 44 poly meshes in there in our scene. And so yeah, then it's going through and it's rendering. So, you know, we're at 15%, and then let's let you know you get a good time rate here. And because you ran this in an actual command line thing itself, you basically have a situation where you know exactly what's going on, and then when you wake up in the morning and your render is done, you basically can go through the whole entire log and see, you know, what was going down, how long things took. You get an idea of, you know, how you need to kind of sort of tweak your scene out, probably, if it's going too long or if it's going too short, or if something happened that was an error. And that's pretty much it for the batch rendering. And so with that, we were able to use Kick and basically render that stuff out. Now, looking at our AS files, if we go into Ultra Edit here, my new favorite text editor here, because it loads massive files, it actually is able to handle files that are relatively big. I mean, Notepad chokes even on like a 20 megabyte file, which is kind of crazy. I've used Sublime Text, it chokes, and Notepad++ also chokes on files that get a little bit bigger than, you know, 10, 15 megabytes. 100 megabyte files, and files like AS files that can be like 200 megs. just choke out most common text editors. So started to use this text editor a little bit. It's expensive, but it's well worth it, and I can use it basically for everything, coding, scripts, and all sorts of kind of cool stuff. But here's your options node right here to start out. There's your AA samples that you set up. There's a bunch of other options that you didn't necessarily set yourself, but Arnold kind of has defaults for those, and it sets those up, the bad pixel and the bad texture. These outputs are for your drivers. So these are basically your AOVs that got exported out from your EXR driver, and then you've got the C4D driver somewhere around here as well, I think. Motion vector Z pass. There's your beauty pass there, the RGBA pass. And here comes the second frame. So yeah, like I said, that could get very annoying very fast. Here's the resolution of your scene. Arnold released a new version that had fast opacity just a couple of months ago, so that seems to be enabled now for faster opacity. Your texture search path is also new in, I think this is Arnold 0.1.0.3.0 that I think he introduced. The guy who's developing this particular plugin for Arnold kind of sort of introduced this in so that you can quickly and easily be able to have all your objects be relative, and it adds all your texture paths automatically for you so that it's very easy for Arnold to find them. Now this you would want to change for your, if you're on the Mac, let's say you're rendering across platforms, so you're rendering on Linux, you're rendering on Mac, and you're rendering on Windows. You could use a Python script or some other type of scripting method to go ahead and find this line and basically change these texture paths to different texture paths, and automatically all your AS files would be updated with new texture paths, and you wouldn't have to actually change anything over or do anything. The procedural search path is right here. This is going to define where it can find OpenVDB, xparticles, all that kind of good stuff. Your gamma, various different things. Then you've got various different nodes for your cameras. The volume scattering is that shader that we created. So this is a shader node that's being defined here. This is the camera node that's being defined, and it's got all the camera information. Here's our EXR driver, and it's defining our EXR options. We could change these manually through text, or we could change these in C4D to A, and so forth and so on. You got lights, you got the sky, everything that defines your scene is basically defined in this AS file. So it's literally a conversion of your whole entire scene. It's basically like a C4D file of sorts. Here's your polymesh with that binary encoding that I was talking about. So it's not very human readable, but trust and believe that this is all defining all the triangles of all that text and those various different little jewel sphere balls that we had in the scene. Alright, and there's multiple polymeshes here being defined for various different, for all the balls and the text and all that kind of good stuff. And then coming down here in the file, you usually find the shaders at the bottom, and they define basically your color and all that kind of good stuff. So that's the AS files in a nutshell. With your procedurals, you'll probably want to open these up and possibly change the texture search paths if you find that your procedurals aren't rendering correctly and different things like that. In advanced workflows with Arnold, you can do some interesting things like bring in an AS file that has just grass or just a bunch of trees, and if they don't need to be re-rendered, you can actually use simplified AS files of just cameras and lights, and then just keep that geometry loaded in memory, basically in Arnold, like a kind of sort of like live rendering session, and you can just load in new cameras and then re-render out another frame with a different driver here, with a different number. So you can see each one of these drivers, that sequence pound symbols got replaced with this actual file. So this file extension. So basically, this as file is rendering out just this one frame, this one type of file, and then each one of these as files basically has a different file extension. But technically, we could render out from Arnold maybe like one file to define the background, and then another as file that defines just the cameras, with each camera having a different driver related to a different number here. And then, you know, we can save a lot of memory and we can kind of sort of be a little bit more efficient. I'll probably discuss that workflow in a lot more detail as I kind of sort of play around with it. But it could be a very interesting way to kind of sort of speed up your renders even more. So Arnold gives you a lot of power with this, and if you're familiar with RenderMan, then you're kind of familiar with the idea of having a human readable, kind of sort of standardized definition of your scene that you can kind of edit. If you go to the user help and user guides on Arnold, they've got plenty of information on how to read these files, what the different options mean, how to use the API, and you can get very, 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 very detailed in your workflow. And that's why a lot of the Hollywood studios really love this renderer, because it allows you to get very, very, very specific about what you're doing. Same reason why they love the RenderMan. Only difference between the two, obviously, is Arnold is a ray tracer, an exceptionally fast one at that. So it's got that advantage of being able to really do nice reflections and refractions and various more realistic motion blurs and depth of fields and different things that a typical rays renderer wasn't able to do in the past. So anyway, that is it for me and for this tutorial series. Thank you for watching this, and thank you for all the donations and pleasant comments that you've left me on my progress with this. In our next tutorial series, I will be going into a lot more detail about various different other nodes in Arnold. I'm going to be starting a Arnold technical series that's going to go into more of a specific workflow for various different types of nodes. Obviously, in this series, we didn't get to discuss the Arnold TP group. I've used that to do grass, where cloners kind of sort of failed and crashed Cinema 4D. This TP group, along with thinking particles, kind of allowed me to be able to get hundreds of thousands of instances of patches of grass onto a plane without actually, you know, crashing C4D. And it also allowed me to go through my scene really, really fast. I'm going over that workflow in another tutorial. OpenVDB, I'll be going over that soon as well and showing you how to bring in those volumes. Hair, obviously. I've created a new plugin on my site actually for hair, allowing you to get dynamic hair from other systems into C4D and then get into the hair object. And I'll be going over a tutorial for that very soon as well, so that you guys can use that and really start to accelerate your hair workflows. Once again, like I said, thank you, and look to that new announcement about the new Patreon page, where we're going to be starting to do project and production based shorts. Well, we'll be showing you how to, like, you know, take a mage character, you know, in a dungeon and have her throw fire at a wall or something like that with full cloth dynamics and stuff. Just break down how the whole entire shot was put together. Or another shot where a character falls out the sky with, you know, hair blowing, and there's hair dynamics and wind blowing the hair and the cloth, and, you know, we might have them punch the ground and, you know, have a lightning bolt come out the sky and different things like that. Just quick shorts with really cool techniques, using all the programs, using Clarice, using Houdini, using Maya, and just combining them all together and just bringing out production shots. Once again, you know, kind of sort of using kind of the techniques that we've worked on here with, you know, keeping your directories nicely organized, making sure that you have texture workflows that allow you to be relative to different things, and all that kind of good stuff. So, See you guys in the next one.